Impulse. What is impulse? When a force is acting on a body or a system, it changes the momentum of system. This momentum of system is equal to the product of force and the time for which force is acting on the body or system. Now, let us see what is known as impulse. When a force F acts on a body for a period of time t, then the product of force and time is known as impulse. It is represented by a letter J. A large force acting on a body for a very short interval of time is called as impulsive force. Impulse J is equal to product of force and time. So, J is equal to F into T. By Newton's second law, force equal to change in momentum by time. F is equal to del P by T. Now, to find del P, multiply force and time. Del P is equal to F into T. In equation 1.7 and 1.8, RHS are equal. So, LHS also equal. Then, impulse J is equal to del P. From this, you know that impulse is also equal to the magnitude of change in momentum. Its unit is kilogram ms minus 1 or Newton second. That is, the unit for force is Newton and time is second. So, unit for impulse is Newton second. This change in momentum can be achieved in two ways. The first one is a large force acting for a short period of time. Second one, a smaller force acting for a longer period of time. Now, let us see examples for impulse. In automobiles, springs and shock absorbers are fitted to reduce jerks while moving on uneven roads. In cricket, a fielder pulls back his hands while catching the ball. He experiences a smaller force for a longer interval of time to catch the ball. It gives lesser impulse on his hands. Now, next topic, Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction. They always act on two different bodies. Let us take two bodies A and B. Body A applies a force Fa on a body B. Then the body B reacts with force Fb on a body A. These two forces Fa and Fb are equal in magnitude but opposite in direction. That is, Fb is equal to minus Fa. Now, let us see the examples for Newton's third law of motion. When birds fly, they push the air downwards with their wings. This is action. And the air pushes the bird upwards. This is reaction. When a person swims, he pushes the water using the hands backwards. This is action. And the water pushes the swimmer in the forward direction is a reaction. When you fire a bullet, the gun recoils backward and the bullet is moving forward is a action, and the gun equalizes this forward action by moving backward is a reaction. Next topic, principle of conservation of linear momentum. If there is no external force acts on an object, then the total system of an object remains constant. So, principle of conservation of momentum states that there is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Let us prove this law. Two bodies A and B having masses m1 and m2 move with initial velocity u1 and u2 in a straight line. The velocity of the first body is higher than that of the second body, that is, u1 is greater than u2. During an interval of t second, both the bodies collide with each other. After the impact, both the bodies move with velocity v1 and v2. Now, force on body B due to A, Fb is equal to m2 v2 minus u2 by t. Force on body A due to B, Fa is equal to m1 v1 minus u1 by t. By Newton's third law of motion, action force is equal to reaction force. That is, Fa is equal to minus Fb. Fa is m1 v1 minus u1 by t is equal to FB is minus m2 v2 minus u2 by t. Now you have to multiply with m1 v1 minus m1 v1 by t is equal to minus m2 v2 minus m2 u2 by t. Cancel t on both sides, then m1 v1 minus m1 u1 is equal to minus m2 v2 minus m2 u2. Now let us bring final velocity to the left side and initial velocity to the right side. m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. The above equation confirms in the absence of an external force, the algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum before collision. Hence, the law of conservation of linear momentum is proved. Now, next topic, rocket propulsion. Propulsion of rocket is based on the law of conservation of linear momentum as well as Newton's third law of motion. Rockets are filled with a fuel in the propellant tank. When the rocket is fired, this fuel is burnt and a hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber. This makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. There is no net external force acting on it. The linear momentum of the system is conserved. The mass of the rocket decreases with altitude. When the mass decreases, the velocity increases. So, there is a gradual increase in velocity of the rocket. At one particular stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Thank you, students.